In collections, as a big thing, we can split into the two types of the collection. One is linear. That means the data structure is looks like a line, linear structure. Array list, linked list, stack, queue are linear. Actually, priority queue is also linear, but we think like a tree. Then set collection is when we use a set. So actually, hash set, tree sets are set collection, and also map is using set. So hash map, tree map are also set collections. So only those four are linear collections, and today we're going to focus on the linear collection. Array list, linked list, when you instantiate, you may use the generic types in the triangular bracket. Then you can instantiate. For the array list, you can give initial size or no size. Array list is always flexible in size, so you need to remember that. And linked list is also very flexible in size. Then stack is also the concrete class Java offers. So if you want to use a stack, you are going to import java.util.stack. It's like a scanner. You are going to import the pre-made stack, the built-in class stack. Then you are going to instantiate stack type object. Then you use it. But queue is different. In Java, queue is interface. Queue is not a concrete class. So you cannot instantiate queue type object like a new queue. No. But linked list implemented queue interface. So whatever queue has to know, linked list has it. So if you want to use a queue data structure, you are going to use polymorphism, super queue reference, refers subclass linked list. Then you are going to use only what queue knows. So only add, remove without any argument, pick, and is empty method. Only those four methods will be used when you use super reference as a queue type. Then stack. Stack knows push, pop, pick, is empty method. In Java, those four methods are what stack knows. Then priority queue is like a queue, but the implementation is different. So let's look at the stack and queue first, because this unit is stacks and queues. Queue is like a regular line. So who comes first will get served first. So whatever you add, you are going to add to the last, and whenever you call remove, you are going to remove from the front. So I can say this one as first come, first out. First in, first out. So regular line. But stack is, you can think about the stack of the card. Whatever you put on the top, you are going to get first. That means whatever you put on the last, so last in will get out first. So first out. So whenever we use a stack, we usually draw the diagram with the upside down head. Then you are going to push the item, the first item, second item, third item. Then whenever you pop, you are going to pop the last third item first. So whatever last into the stack will get out first. This is a what stack. In Java, so every programming language uses different method name. Like for example, you can see enqueue, dequeue method name. But in Java, we use add and remove method for queue. Then in the stack, we use push and pop method. So you can see here stack. That's very important. Last in, first out. This is the very popular diagram to draw the stack. It's still linear, upside down linear. Then the most important thing is whatever method you use in the stack, push, pop, pick, and is empty, all big efficiency is big 1. That means you cannot pop in the middle of the data. You can just pop only the top one. So that's why it's big O1. Push is also big O1 because you just push on the top. Pop, Pick means you're gonna just look at what is on the top. That is also bigger 1. And is empty is also bigger 1. Because it is just checking the size. Then Q also has add, remove, and pick. All those are also bigger 1. Only one difference between stack and queue data structure. Queue is first in, first out order. Then because Java does not have a queue concrete, we are going to use linked list. Then priority queue. Priority queue looks like a queue, but actually the implementation is totally different. Only one thing you need to remember is priority queue, no matter what, it is using the min heap, min value will be on the front. So if I have like a data 1, 2, 3. So I'm gonna use just a heap structure. Heap looks like a tree. Then front is the root. Root has always a minimum value. You can have 1, 2, 3 or 1, 3, 2. Then when I want to add 0, the smaller one, when I want to add like a 4, I'm gonna just add at the end of the list. So it is filling the top to the bottom. So 4 will be added there. After that, if I want to add 0 into this min heap, I'm gonna add at the end first. Then if the parent is bigger than me, swap. Then parent is bigger than me, swap. So after I add 0, the tree becomes, heap becomes 0, 1, 3, 4, 2. So it guarantees root. The front is minimum value, but it does not guarantee this is in order or not. So we do not know what's going to happen in the middle, but we guarantee front is always minimum. That is the priority queue. Because in the queue, we are going to just use remove method. We cannot remove from the middle, just the front will be removed. So it guarantees minimum value will be removed first.